Right, in this video I'm going to try to explain what actually covariance is in a simple way. So here we've got a set of data points here, and someone has worked out the mean value of all the x coordinates of this data and the mean value of all the y coordinates and plotted that point on the graph. What that does, it splits this now into 4 quadrants. This is known as quadrant 1, quadrant 2, quadrant 3, quadrant 4. Now, if we just look at that data, it looks like there's some sort of positive correlation. And what we need to do is, we work out how far the x-coordinate is away from the mean. This is what this value is doing here, and how far the y-coordinate is from the y-coordinate from the mean as well. Okay, and then what we do is multiply those together, and we add them up, and we divide by the number of points that we have. And this is called covariance. So it shows us how the data is connected. Now if I move the points like this, and obviously the means are going to move as I do that, but if I move the points like this, what we're going to see here, I'll try and make them all in a straight line. What we're going to see here is some sort of what's known as positive correlation. Okay, and you can see that most of the points for positive correlation, right, well, there we've almost got perfect correlation there. Most of the points for positive correlation lies in a straight line, lie in the first and the third quadrant, split around the mean point. Okay, and so the covariance calculates that value, and this value here, what's known as the correlation coefficient. If this is like near 1, then we've also got perfect correlation, and this is called positive correlation because the gradient here is in a positive way. Now if we change that so that most of the data is now in quadrant 2 and quadrant 4, just have a look to see what happens here. Okay, we can see that like that. We'll just move some of this over here. Like that. Okay. Alright, now we can see that the data now lies in a straight line going this way, so that's negative gradient, so the correlation coefficient is -1, and the covariance has also become negative as well. Alright, so covariance is a measure of how far each point is away from the mean, the x-coordinates from the mean and the y-coordinates from the mean. It takes a product of those and you divide by the number of points that you have. Now if we spread all the points out on the diagram all over the place, like this, okay, and okay, so all the data is now spread out. We can see there's virtually no correlation. So this number here is actually very close to 0, it's almost 0. Okay, so this value here is called the covariance SXY. This is what the covariance is, SXY, and this is the standard deviation of X, and this is the standard deviation of Y. So this has been a video to show you basically the meaning of covariance and what is the correlation coefficient R. Okay, so if R is between R is always between -1 and 1. -1 mean perfect negative correlation, 1 mean perfect positive correlation, 0 means no correlation whatsoever. Obviously most values lie somewhere between. So if we go back to what we started with, give me a minute to move the points, roughly what we started with everything being in the first and the third quadrants. Okay, here we can see, just move it about. That's it. Let's move it back a little bit. So, okay, here we can see what we know as positive correlation. Okay, we can see the value is quite high. Alright, and we use this value to determine how well the linear regression is. Does it conform to a straight line or not? And this is the numerical value that helps us decide that. Okay, I hope you've understood, and this has been a basic explanation of what's covariance and what is the correlation coefficient. Thank you very much for watching, and I hope you've understood.